As large language models continue to revolutionize the field of artificial intelligence, it's essential to explore various design patterns that can unlock their full potential. One such design pattern is agentic workflows, which enables LLM to autonomously decide on the sequence of steps to execute to accomplish complex tasks. In this video, we will design one such commonly used agent named ReAct agent using pure Python. ReAct agent, based on ReAct prompting method, mimics how humans solve real-world tasks as we reason verbally and take actions to gain information. For the given user query, the ReAct agent starts with a thought on how to solve it. For example, let's say that you ask the agent, what is the last close price of Apple stock? The agent has various tools available, one of which is to retrieve the latest close price of any stock. Its first thought will be that to answer the given question, I need to use a tool last close price with argument AAPL. It will then call the tool to retrieve the latest close price and move on to observation. Observation will be the latest close price of Apple stock. The LLM based on observation will decide whether it needs to call more tools to answer the user query or if it has enough information. In our case of the last close price of Apple stock, the agent has enough information, hence it will return. If it needs more information, then it will again go into the thought action observation loop to call more tools to answer user queries. For this tutorial, we will use open source LLM Llama 3.1 from Meta to build our agent. We will access it through Grok API. So without further ado, let's get started with the coding part. Alright, so as you can see on my screen, I have kept the total code for this tutorial in this Jupyter notebook. And at the beginning of the notebook, I have highlighted the important sections. So in the first section, I will explain you how you can access LLM through Grok API. Then we will define a list of tools or function which our agent will use to retrieve the latest data about any stock ticker. Then we will define the ReAct prompt. So this is the core concept on how this particular thought action observation loop will be performed, and this prompt will go as a system prompt to our LLM. Then we will define agent class and we will perform this thought action observation loop manually, and then we will write a loop to automate the process of calling actions based on a thought and perform this thought action observation loop automatically without any manual intervention. So first of all, I have imported Grok library. So you will need to install it. You can install it using pip install Grok. And then I have loaded environment variables. So the Grok API key is kept in the current directory in .env file. And I am loading it using this load.env function from .env library. And Grok API key is kept in this variable Grok API key. So in the first section, we are accessing our LLM. So for that, you need to log in to console.grok.com and create API key over there. Now for this tutorial, I am using Llama 3.1 with 70 billion parameters version. But there are many other models. If you're interested, you can try them as well. So in order to call Grok API, we first need to create a client. For that, we need to import this Grok class, and then we can create an instance of Grok class by giving API key, which is our Grok API key. So this will be client. And once the client is created, we can call any model. So for that, we need to call client.chat.completions.create method. And there we need to provide two parameters, messages and model. So messages is the total chat history, and it will have role either user or assistant or system. So if first one is system, and the user one will have the user query, and assistant will have a response from the particular model Llama 3.1 in our case. And the response will be available as chat completion, and there is a parameter. So there is attribute choices and of zeroth choices dot message dot content. So this will print the response from the LLM. So I have a simple question, hello, how are you? And it has replied that I am just a language model. So that's how you can call LLM through Grok API. Next, I have defined list of tools. So these are list of functions which can be used to retrieve the latest data about any stock ticker. So for that, you will need to install this Yahoo Finance library. So you can install it using pip install. So first of all, I have imported the library. And the first tool or function is the company address, and it takes as input the ticker. And then there is a doc which explains that what this function does. So it returns a company address based on the input ticker. So that's how you can use it, company address, and ticker is AAPL for Apple. So first of all, we create an instance of ticker based on the given input ticker. So that will be the ticker object. And this ticker object has a method named getInfo. Calling this method will return a dictionary. So it's a very long and big dictionary which has a lot of information about the particular given ticker. And from that dictionary, we will retrieve information for this given keys: address, one, city, state, zip, and country. And for each key, we will retrieve the values and then we will combine them. So we will have the complete address of the given ticker. So that will be the use of this tool to retrieve the company address. Next tool is a full-time employees. So if you want to know how many employees are there, full-time employees in the company, again, it has a same structure as our previous tool. So it takes as input ticker. It will create a ticker object and call this getInfo method on it. And there is an attribute name, there is a key name full-time employees inside of that info dictionary, which has information about number of employees. So all other tools are simply same as the previous tools. So last close price, again, it takes as input ticker, and the dictionary info has a key name previous close, which has the last close price. Same way we can retrieve EBITDA. So there is a key name EBITDA. There is a key for total debt as well inside of this info dictionary, total debt. We can also retrieve total revenue, and we can also retrieve debt to equity ratio. So there is a key name debt to equity, which has debt to equity ratios. So these are list of tools or function which our LLM can use to retrieve this information, latest information from the net using these tools. So it does not have obsolete information. So I have maintained this tools variable, which is list, and inside of this list there are all these tools one after another. Next, I have created a simple variable named tools with description. So this variable is a string, long string, and it has information about all the tools. So name of the tools and what is the doc. So doc will be the what that tool does and how to use it. So I'm simply looping through tools for tool in tools, and I'm retrieving the name of the tool and tool doc, and I'm simply combining them. So that's what is happening over here. This is the tool name and this is the tool doc, and after each of them I am simply adding new lines. So this will be the description, complete string description describing all the tools that we have available, and we will need this. Next comes the most important part of our tutorial, which is the ReAct prompt, and this is the system prompt which will be given to LLM, and that system prompt has information about that thought, action, observation loop. So let me walk you through this particular prompt. So as you can see, you run in a loop of thought, action, pause, and observation. So pause is where we will execute the tools, the actions which are suggested by the LLM. We have list of actions, and based on the query, the LLM will decide which action or tool to execute, and that we will execute after pause. And that response will be going inside the observation. So at the end of the loop, you output an answer. Use thought to describe your thoughts about the question you have been asked. Use action to run one of the actions available to you. Then return pause. So after printing the action, it will pause so we can execute that action. And observation will be the result of running those actions. And your available actions are this. So tools with this is the description is the variable which we created over here. So this string, long string, and that will be appended over here. So all the available actions the LLM will have. And then there is an example session. So there is one example over here which explains how the LLM should behave. So first, the user input will be query that what is the last close price of Apple stock? And the thought from the LLM side will be that I should retrieve the last close price using last close price tool. And action will be the last close price, and input to that tool will be AAPL. Now AAPL is a ticker for Apple stock, and LLM was able to retrieve it by itself, and then it will print pause and it will return. So once that happens, we will call this function last close price with Apple AAPL, it will return the latest close price. So you will be called again with this, and then we will call LLM again with this observation, which will be set to this price, which is the response from call to this particular tool. And the LLM then will output that answer is that the last close price of Apple stock is 223.96 USD. So that's the system prompt which is responsible for this React agent. So over here I have simply printed the total prompt. So here is the prompt, and here is all the actions which are available, and then there is the example session. So now that we have defined the system prompt for React method or React agent, we can define our agent. So over here I have created a simple agent class, and then we are initializing this agent class over here. So it takes a system message. If you are providing some system messages input, then it will be stored as a self.system, and self.messages is a complete chat history. So every time you call this agent with a new query, those messages along with the response from LLM will be appended in this messages list. The total chat history will be available. Now if you have provided some self system message, then that will be appended first to the list of messages with role as system, and content is the system message. So this is a standard format used by all the APIs. And then there I have implemented call method. So this will be executed when we call the instance of agent class, and we can call the instance with single message. So that message will be appended to the list of messages with the role set to user, because that will be user query. And once we have appended it to messages, we execute the LLM. So we will call the LLM and retrieve the latest response from the LLM for the user query. And that response will again be appended to the list of messages. So role will be assistant because it's a response from API from LLM. So that result will be appended, and that result will be written as well because we will print it. And this execute method, which we called over here. So here is that method, and in this method we are simply calling our Grok API. So client.chat.completions.create with this model, and messages are self.messages. So messages, last messages over here will be the user message or user query that will be present, and that will return result, and that result we will return from here from execute, which is coming over here. Every time you call an agent, it will call the Grok API and retrieve the latest results. So total messages will be over here, self.messages. So after defining the class, over here I have simply initialized our React agent. So I have created an instance of agent class with the system prompt which we declared earlier. So that will be the React agent, and we can call our React agent like this. So first of all, I have asked it a very simple query that what is the EBI TDA of NVIDIA, and result is over here. So I'm printing the result. So as you can see from the response, it went into the thought action loop, and the first thought is that I should retrieve the EBI TDA using the EBI TDA actions. So EBI TDA is one of the actions available to it, and the action name over here is properly written EBI TDA. And for NVIDIA, the input is NVDA, which is the ticker of NVIDIA. So we can call the EBI TDA tool over here, as you can see, EBI TDA with the input argument NVDA, and that will be the tool result. So as you can see, this is the EBI TDA of NVIDIA. So now we have the EBI TDA. So we can create a next prompt, which will be observation, and observation will have a tool response. So this tool result will go over here. So this will be the next prompt to our agent. Observation is this. So when we call the React agent again with this next prompt, so this observation will be appended to the list of messages, and the Grok API will be called again with this observation. So based on the complete history, it will generate answer that EBI TDA of NVIDIA is 49.275 billion USD. So as you can see, it went into complete thought, action, and observation loop. And as over here, we are manually calling this function, but in the next section, we will automate it through a loop. So let's try a few more queries. So in the first query, I asked a question about only single stock, but let's go ahead and ask a question which requires usage of more than one tool. So we can see that how many times that thought, action, and observation loop is getting performed. So over here, I'm asking that what is the EBI TDA and debt to equity ratio of Google. So I'm printing the result. So first it went into thought that I should retrieve EBITDA and debt to equity ratio using EBITDA and debt underscore to underscore equity underscore ratio actions. And then first action is EBITDA with input as GOOGL. So this is the ticker of Google. So I'm calling that a particular tool and creating a next prompt, which is the response from that tool observation. And I'm again calling the React agent with that observation. So the result over here is that again it went into the thought action loop, because now it's saying that I have EBITDA. Now I need debt to equity ratio. So for that, it is calling the action debt to equity ratio. So this is the second tool that it's calling, again with ticker GOOGL. So next I'm again calling that tool. So this is the second time we are into the loop of thought action observation. So that's the observation, and that will be the observation will be the result of calling this particular tool. And again I'm calling the React agent with the next prompt, which is the response of calling this tool. And now the result is that the LLM is completely generating answer that the EBITDA of Google is 115.478 billion USD, and the debt to equity ratio is 8.295. So based on the complete history, it generated the answer. So next, I'm trying one more query to show you that how it's calling more than one tool, how it will go into the thought action observation loop more than once. So over here, I'm asking it to compare the total revenue of Apple and Nvidia. And the result again is thought that I should retrieve the total revenue of Apple and Nvidia using total revenue action. So first time it's calling total revenue with AAPL, and that's the ticker of Apple. So calling that particular tool, retrieving the result, calling the agent again. This time its thought is that I have a total revenue of Apple. Now I need the total revenue of Nvidia. So again calling the total revenue function with NVDA, which is the ticker of Nvidia. Over here I am calling the total revenue function or tool, generating the response observation, and again calling the next prompt and React agent with the next prompt, which is the response of calling total revenue for Nvidia. And this time it generated answer because it has a response for both Nvidia and Apple. So the total revenue of Apple is 381.623 billion USD, and the total revenue of Nvidia is 79.774 billion USD. Now sometimes for this one it answers that the Apple's revenue is much more higher than Nvidia, but it depends because it's randomly generate answers. There is some amount of randomization. That's why answer will be a bit different this time. But it properly went into the thought action loop 2 times to retrieve the total revenue of Apple and Nvidia. So in this section, as you can see, we manually performed this action. So we manually executed these actions based on this. So in the next section, I will explain you how we can automate this process of calling the tools based on the response of this LLM. So in this section, I have explained that how you can automate this total loop of thought, action, and observation. In the previous section, we manually called the tools based on the action, the prompt response generated by the LLM. But in this section, we will try to automate it. So we will create a simple function which takes the user queries, and then it will go into the loop completely calling as many tools it needs and generate the answer. So first of all, over here, I have declared a dictionary, non-actions dictionary. And it's a simple dictionary which is mapping from the name of the tool to that tool function. So we can use this dictionary to retrieve the particular tool based on its name. And over here, I have declared a simple function. This function takes the user query as input, and then it will go into the thought, action, and observation loop, call the tools it needs, and generate the final response. So first of all, I have declared a regular expression over here. So that expression looks for the line which starts with action, and then the name of the action and the argument. These two things are retrieved using this particular regular expression. And in this particular function, I have set max turns to 5. So this will go into the loop of thought, action, and observations 5 times. So maximum it will go till 5 times only. So if you are writing some query which needs to execute more than 5 tools, then you can set this max turns to like 10 or whatever highest argument. So first of all, I am initializing our React agent with our system prompt. And the next prompt is set to the input question. And then we go into the loop. So inside of the loop, first of all, I am calling the React agent with the next prompt. So for the first time, it will be the user query and whatever result will be printed over here. So this will be the thought and action. And based on the result, we are retrieving the list of actions. So over here, I am splitting the response based on the new line. So for each line, I am checking whether the action is available there or not. So those actions will be available over here. And generally it will be a single action. So if actions is available, then we go over here. And if there is no actions, which means that the response is generated, then we return. So if action is available, then we retrieve actions of 0 dot groups. So this will return two things. The first one over here, this one will be the name of the action, so name of our tool. And second one over here, so this will be the action input. And first we check that whether the action is there in list of known actions. If it is not, then we raise an exception. But if it is there, then we print a message that we are executing this action. So then we execute the action. So we call this known actions dictionary with the action name, and this will return us the tool. And then we call that tool with this action input argument. And that will be the observation. So next prompt is set to observation, and that observation is a response from this particular tool call. And then again it will go into the loop, and next prompt will be the observation from the tool, so that it will check whether it needs to call more tools, and if it needs to, then the actions will be present, otherwise it will return. So this is the simple function we have defined. So let's call it. So over here, simple call to this function will do all the thought, action, and observation loop. So over here I asked that compare the total revenue of Apple and Nvidia, and we did this process manually. So over here thought, it says that I need to compare this and I need to use this tool, total revenue. So first it went to action total revenue with AAPL for Apple. It retrieved this observation, and then thought is that I have the total revenue of Apple. Now I need the total revenue of Nvidia. It's called total revenue with Nvidia, running that particular tool with the observation this, and I now have the revenue, so I can compare them. So answer is that the total revenue of Apple is this, and the total revenue of Nvidia is this. And over here it's generated extra string that Apple's total revenue is significantly higher than Nvidia's. Now the answers generated by our React prompt are generally quite simple, but if you want it to elaborate, then you can add more system message which explains that expand the answer generated by the tools and write some more lines explaining the response. But in our case, it's generating a simple response based on the tools, it retrieving latest information. So next time trying our query function with one more query. So this time I asked it the question that what is the EBITDA and debt to equity ratio of Google? And again, it went into the thought, action, and observation loop. So first it decided to call this action EBITDA with argument GWGL. So that's what we are executing, retrieving the observation. And now the thought that I have EBITDA, so now I need debt to equity ratio. And for that, it's calling this action debt to equity ratio with GWGL. So this is the response. And now it's saying that I have both EBITDA and debt to equity ratio. So I can provide answer. And this is the answer, that EBITDA of Google is this and debt to equity ratio is this. Alright, so that's how you can create a React agent in pure Python using open source LLMs available through Grok. If you have any doubts or any questions, then please feel free to let me know in the comment section, and see you next time.